Show you how to solve Leetcode question 230, k smallest element in a binary search tree. So it gives you a root of a binary search tree and also an integer k. So return the k smallest value. The k is one index of all the values in the nodes in the tree. So that means that the k starts from 1 instead of 0. For this example here, if you look at this tree and k equals to 1, that means it's looking for the first, basically the most smallest value. By looking at the tree here, binary search tree, the left side, the node value is smaller than the root, and the right side is bigger than the root. And you can see it is a binary search tree, and the most smallest one is 1, so it return value as 1. And if you look at this example here, and the k equals to 3, so the third smallest, if you look at this here, it's basically 1, 2, 3. The third smallest is 3, so it return value as 3 here. And if you look at here, there's some constraint, and then there's some follow-up question here. And this is a question asked by many companies like Uber 10 times in the last 6 months. So it's definitely a great question to practice on. If you look at this, for example, like this one here, and you can see that the sequence it go through this tree is actually an in-order traversal. In-order traversal of the tree is actually from the left node, and then the root, and the right node, and then pop back up and to the root, and then back up to the root 3, and then to the right node. That will be the sequence. That's how you actually will how you will kind of sort this value, and then we'll be able to return the right output and based on the kth. And if you look at here is the in order traversal is 1, 2, 3, 4 in this case. So that's exactly what we're looking for. And the most easy way to solve this problem is probably do this recursively and just have like a defer search and just do recursively traverse to the entire tree and return the call the same function to start this traverse this node from node.left, and then add the root node and then the right node, right? And then once you have this output, and then you pick the k minus 1 value, is basically the k minus 1 is because everything starts from 0 index, the while k is 1 index, so you need to minus 1 in this case. And this is probably the most easy way that you can do it. And the other way is you can do this iteratively, go through every single element, and then what you need to do is you will need to get a help from a stack. And when you do from the stack, right, you also wanted to continue to append the value. So in this case, you want to append the value as append the root first, right? And then you want to continue to add all the value to the left until there is no value on the left anymore. And then once there's nothing left on after the 1, right? Because the 2 is actually a right node, so you don't add it in this case. And then that's how the in order traversal is. And once you start doing that, you start popping from the queue. So then when you pop, you pop 1 first, right? After you pop 1, the node value will be 1 in this case. And then you pop whatever you pop, I'll say popped is 1, right, in this case. And then you want to decrease every time when you pop, you want to decrease the count for the k. And when k equals to 0, that means you found this number. So in this case, that k equals to 1, and when we pop the 1 out, right, and then k minus 1 equals to 0. So that means that we already found this value. So you return this value, basically is 1 in this case. And then if let's say k equals to 2 in this case, or even equals to 3, then you have to continue to pop from the queue. And then basically after you add you remove this value 1, and then you have to move to the right side. If after you find if k is still not equal to 0, then you have to make sure the root is moved to the right node. That's basically the sequence. In order is left, root, and the right. And I'll show you how to do this in code, and you will understand this better. And I'm gonna show you how to do this first using like recursively, and this is how you do it. And let's say you create a function called in order, and then you basically start from a node, right? And what you essentially you want to return is you want to call the in order function on the node.left, because it's from the node.left, right? And then you want the node.left plus the node.vol basically is the root value, and then you want to move to the right side. You also wanted to call the in order function on the node.right. That's basically the sequence, right? That will be exactly what you need to return, and it will, since you are doing this way, it will call this function continuously. And if node, that's under the condition if the node exists, right? If not, does not exist, and then you just return empty. And then in the end, this is when you call the function, essentially you just want to return the in order function, and then you pass the root value to it. But you don't need everything. All you need to do is just the k minus 1 value, which will be the kth smallest that you're looking for. And then if you run this, yep. So that's the recursive way. And I'm also going to show you how to do this iteratively. And then you can use our stack here. So basically, while root, it's a root does not equal to 0, or the stack has a value exist. So I want to go through the root, and then I'm gonna start append values to the stack first, and I'm gonna append the root first, and then I'm gonna shift root to root.left, and I'm gonna also, once you do this, well, because it's while root, that means that you're gonna continue to append the value to the stack until you append everything on the left node. Like a 3, you're gonna append a 3 and append a 1. There's nothing on the left anymore. That's the while root, right? After you complete the while root step, and then you're gonna start popping from the stack, and the stack pop, and then that is the root. And then you set the root equals to whatever value that the stack popped from. So in this case, the current root, after you added a 1, it will start popping from, it will pop 1 first, and then the root will equal to 1. And then k, every single time you pop once, the k needs to minus 1, because every time you pop, you found the 1 value, right? So that's why you need to minus 1. So if k equals to 0, that means that you already found this value that you're looking for. At that time, you want to return the root.vol. Basically, whatever the root is. In this case, it's 1, right? 1 k, the value you popped from the stack is also 1. And then k is equals to 1 in this case, and you minus 1 is equals to 0 already. So that's why the output is 1 in this case. But if if you still have not find a value, after it pop, and if k is not equals to 0, then you need to continue the iteration to root.right. So basically you already added, and then you're gonna move to the right side of the node, like 2 in this case, and then move on to 4 in this case. That's it for the function. Yep. If you think this is helpful, please like my video and subscribe to my channel, and I'll see you soon with more Leetcode questions. Bye bye.